And everything is fine before we get started. Hello, hello. Hello, hello, hello. Like I was able to solve first 6 problems, so I'm planning to discuss solutions of the first 6 problems. Like people in the chat, like how many problems were you guys able to solve? This will give me some idea on like which problems I should focus more on and which we can probably move faster. Three, two, two, four, three, and by the way, 1, 4. And is audio and everything fine before we get started? A and C. Okay. Looks like most people are in range 3 and 4 problems. So yeah. And like is audio and everything fine before we get started? Okay, everything is good. Okay, let's get started. Okay, first problem says there are two screens which can display sequence of uppercase Latin letters. Initially, both the screen display nothing. In 1 second, you can do one of the following actions. Choose a screen and in uppercase Latin letters, append that character to the end of the screen displayed on that screen. Choose the screen and copy the sequence from it to the other screen, overwriting the sequence that was displayed on the other screen. You have to calculate minimum number of seconds you have to spend so that first screen displays sequence S and second screen displays sequence T. So like if you look at the examples here, like first screen we want garage and on second screen we want garage for sale. So like the idea is like if we do not do this operation at all, then the number of operations required would be number of characters we want on the first screen and number of operations we want on the second screen. And which in this case would be sum of these length of these two. And like the other idea we have is like we first take one screen, we write some letters to it, copy that part to the second screen, and now write remaining characters on all of the screens. Because you see, like when you make a like let's try out some examples here to better understand like what's going on here. So let's say like first we write A, B, C on the second screen, A, C on the first screen, and then let's say we copy this characters over here. So this becomes A, this becomes C. So you see now there was no point in writing A, B before copying this character here. And now let's say we write A, C, C. D, D and D, C, and let's say we copy this character here. Let's first keep it AC. And let's say now we copy this, like, let's say now we copy these three characters here first. So this screen becomes A, C, C. And now you see like there was no impact of copying these two characters here. We could have directly written A, C, C, copy this part here, and then write the remaining character here. So yes, the important observation here was we will do second operation only once, and we will first decide what characters we want to copy, and then we will first write those characters on one string, copy it to the other string, and write the remaining characters. For example, garage. Like let's say we want to write these two strings here. The idea would be we will first write G GAR on the first string, copy this to the second string, and then write the remaining characters. So overall, like the time taken would be like length of S plus length of T plus one copy operation minus I, which is the number of characters we initially wrote and copied. Basically the characters we have saved so far. And like, so the idea is like we should first look at S and T, find the longest string which is part of both the strings. For example, in this case, GAR, like three starting characters are common here. So like the answer here is this, which is 6 plus 1 for copying minus 3, which would be around 10 operations here. And you see, like we first wrote 3 characters, copied it, total 4 characters, and then 3 remaining characters, 10 characters here. So the longest common prefix is what we need over here. And if I jump onto the code for this one, the idea is first I take S and to both the strings, and then I count the number of equal starting characters in both the strings. And the operation is, if I do nothing, the length of both the strings would be the operations I need. Otherwise, the length of both the operations minus I would be the characters I have saved and one copy operations. And the answer is minimum of both of these. Any questions on the first problem before you move on to the second problem? Okay, like the main idea is, like first we will decide how much characters we want to copy, and the main idea is we will do copy operations only once. There is no point in first writing 2 characters, copying it to the other string, and then writing the third characters and copying all the characters to the first string or the other way around. So the idea is we first decide how many characters we want to write in one character, copy in the second string, and then write all the remaining characters here. So one idea is like we never really copy anything, we write each character one by one. So the total number of characters written is length of both the strings. Or if you want to write some characters, then we can first count how many starting characters are equal. And once we know like how many starting characters are equal, then we can first write those equal characters on one string, copy it to the second string, and then write the remaining strings. So for example, like S has, let's say, 10 characters, T has, let's say, 15 characters, and first 6 characters are equal. So the idea would be to first write these 6 characters, copy on the second part, and then write remaining 4 characters and remaining 9 characters here. So overall 6 plus 1 plus 4 plus 9 characters we need, which would be around 20. And like this was the idea. And yeah, like probably I can write a code a bit better, but I think we can probably move on to the second problem now. Okay, I will now move to B. Problem D says recently Aksim met a task that needed binary coefficient to solve. He wrote a code he usually does that looked like this. For all from 1 to n, C n0 is 1, C nn is 1. And for all k equal to 1 to this, C nk is C nk minus 1 plus C n minus 1 k minus 1. Unfortunately, he made the error since the right formula is n minus 1 k plus n minus 1 k minus 1. You notice the difference, minus 1 from here to has been moved to here. But this team member K is interested in the values that were produced using the wrong formula. Please help him find these coefficients for t various pairs ni ki. Note that they should be calculated according to the first strong formula, and since the values can be large, print it modulo this. So probably let's just try to see like what is happening here. Like this is how the table C looks like this. Yeah, this is zeroth row, zeroth column. First row, first column. This would be second row, second column. Third row, third column. And let's say fourth row, fourth column. This is what we need. If we do a for loop, when we are running it for 0, we will directly assign it 1 and we will do nothing. When we are for n equal to 1, we will assign these two values 1 and like this for loop will never be triggered. When we are for n equal to 2, we will first assign these two values as 1. And then when we are at this value, we will take sum of these two values. You see n minus 1 k minus 1 and n minus 1 k. Like basically sum of these two values. This is n minus 1 k and this is n minus 1 k minus 1. And sum of these two values is 2 here. When we are at n equal to 3, we will directly write this as 1 and 1. This is nk minus 1, sorry. This is essentially sum of these two values here. One second. Nk minus 1 and n minus 1 k minus 1. Sorry, this is sum of these two. I got a bit confused. And this is 2 here. Now when we are here, we will again look at nk minus 1 and n minus 1 k minus 1, which would be sum of these two values, which is again 2. Now when we want to fill in these values, we will take n and k minus 1 and n minus 1 k minus 1, essentially sum of these two values, which would be 4. And now like when we are at n equal to 4, we will first write these values as 1 and 1. And when we are here, we will need n k minus 1 and n minus 1 k minus 1, essentially sum of these two values, which is again 2. When we are here, we will take n minus 1 k minus 1 and n k minus 1, which is essentially sum of these two values, which is 4. And when we are here, we will take n k minus 1 and n minus 1 k minus 1, which is essentially sum of these two values, which is 8. Now you can see a pattern here. Like 1 second. So if you see like this table looks like this. And essentially what we know can, based on this table, what we can say is if k equal to 0 or k equal to n, C of n comma k is 1. Otherwise n comma k would be 2 to the power k. And now once you realize this, you can prove it by induction. But yeah, essentially that's how I essentially did it. Yeah, I wrote like these tables on a pen and paper and I saw like these are powers of flow. And now like once we know these values, we can solve the remaining part. So when it comes to the solution, like I was using modular arithmetic, but yeah, like n k greater than 0 and k less than n was given here, but so that's why the code looks like this. First I took all n and k as input, then I printed power of k with the given mode. Like I am using mint library from Edcoder, so I directly have this function. Other way around, you can pre-compute all 2 to the power k for 1 less than k and less than n for all the value. Like you can notice that in the constraint, like k was up to 10 to the 5 for 5 only. So you can pre-compute this for all the given values mod also, and then directly use that pre-compute. Yeah, like I have a video on like how to install AdCoder library. You can just check it, and like Amint was a part of that only. Like has include AdCoder modent, and this is the idea. Like you can just check out the video I have on the channel, like how to use AdCoder library. So essentially, this ends up being the solution for this problem. Any questions on this problem before we move on to the next problem? Okay, I will jump into problem enough. No, pre-compute does not mean hashing. Like you can just run a for loop like this. Vector int p of size 10 to the power 5 plus 1. P0 is 1 for I equal to 1 to 10 to the power 5. Pi is 2 times 2 to the power I minus 1 percent modulo. Okay, like I will now probably jump on to the next problem if there are no more questions on this problem or any questions on this problem. Like the idea was like you create an array of size like 2 to the power, like array, like you know that k is up to 2 to 10 to the power 5, right? K is up to 1 to the power 5. So you just calculate what would be the value of 2 to the power I with the given mod, and then you can directly use that value as well. Or you can use mod power function each time that 2 works, like anything works. The important observation was to realize it's 2 to the power k. Yes, you can also use binary exponential here, exponentiation here. Okay, I will now jump on to problem C. It says there is a new game monocap wants to play. The game uses a deck of n cards, where the ith card has exactly one integer AI written on it. At the beginning of the game on the first turn, monocap can take any card from the deck. During each subsequent turn, monocap can take exactly one card that is either the same as the number on the card taken on the previous turn, or a number that is one greater than the number taken on the card in the previous turn. In other words, if on the previous turn monocap took a card with number x, then on the current turn he can either take card with number x or a card with number x plus 1. Monocap can take any card which meets that condition regardless of its position in the deck. After monocap takes a card on the current turn, it is removed from the deck. According to the rules of the game, the number of distinct numbers written on the cards that monocap has taken must not exceed k. If after a turn monocap cannot take a card without violating the described rule, the game ends. Your task is to determine the maximum number of cards that monocap can take from the deck during the game, given that the first turn he can take any card. So probably let's just pick this sample because like this has large number of values here. Okay, like let's say we can take X 3 distinct cards. Like there are two ideas. Either you can use two pointer or you can use sliding window, whatever you want. 4, 5, 4, 4, 6, 5, 4, 4, 6. Like this is the given set of cards given to us. Like what if I am monocap? What I will do is like I will first take 4 here. And let's say I have taken this card. This is now removed from the table. I will again take 4 here. So this 4 is also removed. I can again take 4 here. Like let's just take all the 4s one by one. The idea is if I take 5 now, then I won't be able to take this 4 again. So let's just take all the possible 4s we want here. Now once we are done with the 4, let's pick 5 because 5 is one more than 4 here. And once I am done with 5, I can take all the 6 here. Like I can take first this 6 and then this 6. This way I will be able to take all the cards. If you see it, like total number of distinct values here is only 3 and problem statement allows us only 3 here. And like all the values are taken, like whenever I took a new value, it was either equal to previous value or just one more than the previous value. This is how the third sample is working. Or in general, what we can do is like we can look at all the, like we can use 2 pointer here. First, let's sort the array. So that all the value, the reason I am sorting here is like AI would be less than AI plus 1. All equal values would be together. And plus 1 value will be just after if it exists. Like so essentially, like if you look at, and here if you notice, like the values I have taken here is equal to the sorted array over here as well. So my idea is to use 2 pointers here. Like let's first create the sorted array. 1, 2, 3, 4, 4, 5, 5, 6, 6, 6, 7. Yeah. And let's say k is equal to 3. The idea is like if I take 1 in the starting, then after this one I will take this 2 and I will take this 3. And this is the best I can do. I won't be able to take any more value here. Let's say if I took this 2 first, then I will take this 2, this 3 and this 4 as well. After that I will not have more than distinct values here. So this would be the idea. Now let's say I took this value on the first one. Then after this 3 I would be able to take this 4 and then this 5 too. After that I won't be able to take any more value here. Let's say I took this 4 on the first one, then I will take this 4 and then this 5 only. Although I have only 2 distinct values, I will not be able to take 8 because 6 and 7 are missing here. And similarly you can see I can keep going over here like this. This in the next turn, this in the remaining turn, and then this green as well. Then this 8, 9 in the next turns, and then just this 9 here, and then this 11 here. And overall the maximum I would get over here is when I take this 3, 4, 4, 5, 5. This would be the maximum test case, and here the answer would be 5. So this would be essentially my idea for this problem. Like you see, like it's like 2 pointers. Like whenever we are moving a left boundary, you see right boundary is also moving a bit further here. Like first, this was our boundary. Next time, when you move from here, your boundary became this. Like the next point you always took is always more than what you previously took. Then when you move to 3, you got this boundary here. You could not go past this, so even for 4 and 5, the right boundary was here as well. And essentially this was the idea. Like binary search can also work here, but you will have to be a bit careful over cases like this. Like let's say k was 5 here. Then also like from 1 to 5, k was 4 here, let's say. You can't just take everything between 4 to 8 here because 6 and 7 are missing here. So you will have to ensure that not only you look at the difference from your current value and the right index up to which you go, you have to also ensure that the difference of every value between that boundary is also less than equal to 1. So even for 131 case, no, I don't think we can do it with hashing. 131, we will first sort it. Then if we choose the starting one, then we will be able to take these two ones. If we take this one, then we will only be taking this one. And if we take this 3, we will take this 3 only. And the maximum is the box in blue. So overall the answer here is 2. If I had to show my code here, what I did was I first took everything as input. Then like the right boundary we want to pick, like what is the maximum index which we can, minimum index which we cannot pick. So I am increasing my right boundary one by one. And like because I am at L, I can always take L. And then I can take the next I will probably start by looking at L plus 1 here. As long as like right boundary is less than N. And if the difference between the next character, like the idea here is, I have this L boundary and this R. I first see like probably I will change my implementation a bit. If I have one more character with me and R plus 1, like the difference is less than 1, and like R plus 1 is the total number of distinct characters I have taken is also less than R, then I can keep increasing the count, and whatever is the length of sub array I have taken so far would be my maximum I can take with this array. So essentially that's the idea. Like I maintain up to which character I want. Like R is like the from L2, if I have fixed my left character, R is the index up to which I can take something. So I have taken some sub array here, and then I see like can I take the next character as well. I can take the next character only if the next value exists, and the difference of next value and the previous value I have taken is either 0 or 1, and total number of distinct characters I have taken are less than k, which is essentially like AL would be the smallest character I can take. Then I can take AL plus 1, AL plus 2 up to AL plus k minus 1 characters. So this difference must be less than k as well. If both of these conditions are satisfied, I can increase my right boundary a bit by one. And then I can maximize the answer with whatever the current boundary I have. So this was the idea. Like the technique I have used here is 2-pointer. And like there is a user guide over here as well. Any questions on problem C before we jump on to the next problem? Yeah, it's a good question. Like, why this is not n square? Because the idea you see is like you are increasing L only n times, and you are always increasing a value of R, and value of R can go up to n only. So like, although it looks like two for loops, so it should be n square, but you see like L is increased only n times, and R is also increased only n times. So like, this loop runs n times, and if you look at how many times this loop runs across all the above for loops, this will also run only n times. And that is the reason why this is not n square, but rather order n approach here and n log n for sorting. And yeah, like this is the key why this is not n square, and like this is what like probably 2-point approaches. Like the idea is like you separately, instead of like generally you see two for loops, you look up to which how many times it can go over here, and you just multiply those values. But the crux here is like this runs n times, but over all the times this while loop is running across multiple different L's, this also runs only n times. Like you don't restart. Like if this was my concern, then this would have been order n square. Because I am not increasing the value of L until I am done. That's why this is order. Or probably other way to write is R less than L. If you look at it like this, you see like value of R is always increasing, and it can go up to n only, n minus 1 only, and value of L is always increasing, and it can go up to L only. And that is the reason why this is order n square. Yeah, T we all call like 2n is also n because we don't count the constant here. So any questions on problem C before we move on to problem D? Okay, the problem D says attribute check. Imagine a game where you play as a character that has two attributes, strength and intelligence, that are at 0 level initially. During the game, you will acquire M attribute points that allow you to increase your attribute level. 1 point will increase one of the attribute by 1 level. Like you can decide whether you want to increase strength or you want to increase intelligence. Spending some time, you finally prepared a list which contains all the points you got and all the. Okay, 1 second. During the game, but sometimes you will encounter so-called attribute check. If your corresponding attribute is high enough, you will pass it, otherwise you will fail it. Hello, hello. Voice is breaking. Hello, hello. Hello, hello. Okay, it's good now. Great. So like TLDR was, we have two attributes, strength and intelligence. Both of them are 0 initially. We will acquire M attribute points that allow us to increase some attribute levels. And using one attribute point, we can either increase strength or we can increase intelligence. And we will sometimes have attribute checks as well. Like, and if attribute is high enough, whenever we have that check, we will acquire some points for it, otherwise we will fail it. Spending some time, you finally prepared a list which contains record of all the points you got and all the checks you have met. And now you are wondering what is the maximum number of attribute check you can pass in a single run if you spend points wisely. Note that you cannot change the order of records. So essentially what it says is like we have to wisely decide whether we want to increase strength at some time or intelligence at some time, so that we pass maximum number of checks we can get. And what is that maximum check we have? And the input format is like M is up to 5000, N is up to 286, Second line contains some variable ri, which is between this thing. If ri is 0, it means like we have acquired 1 point. So we can increase either strength or intelligence by 1. If ri is greater than 0, then it's an intelligence check, and we pass it if our current intelligence is greater than equal to absolute value of whatever ri. If ri is less than 0, then it's a strength check, and we pass it if our current strength is greater than absolute value of ri. And additional constraint is that in the sequence there are exactly m elements equal to 0 we have. So any questions on the problem statement first before we jump on to the solution here? Or like, should I dry run one of the examples here? Like, you can let me know which example should I dry run. So the idea here is probably like, there are many ideas involved here. So I have just started D. Like the idea is, first idea is like, let's define some DP. I strength, S for strength, and X for strength, Y for attributes. This DP says like we have process first I queries. Our current strength is equal to X, and current intelligence is equal to Y. And this value is maximum number of checks we have passed so far. So like overall, like this is order n cube, but do you see like how do you solve it from this error? Like from this DP, like overall this DP would be n into m square, but that's fine. But like, do you see like with this DP state, how are you going to solve this problem? The idea would be whenever we have Ri equal to 0, if we increase strength, then we can do dpr x plus 1 y is equal to max with dpi minus 1 x and y. And if we want to increase intelligence, then we can probably do it the other way here. Would be max like I minus 1 x and y, and along with current value. And whenever we have, let's say, strength check, then for all x greater than equal to Ri, do plus 1. And intelligence check, like for all y greater than equal to Ri, like absolute value of Ri, whatever we have, do plus 1 on that segment here. So like any questions, like before I optimize this, like can you guys able to solve this problem in this time complexity? Definitely at TLE, but can you solve it? Yes, no in the chat. Like just realized my laptop battery is dying. So yeah. Yeah, now the next idea I have is The next idea I have is like we should never waste this. We should always use this attribute point to either increase strength or intelligence. There is no point in ignoring this. Because you see, like whatever solution, maximum number of checks you can get, if you add some ignored point to somewhere else, you can potentially increase the number of strength check and decrease check here. So like for all I, like x plus y should always be equal to number of rj equal to 0 where j is less than equal to y. And like that's the idea. Like probably now the other way to define this dp would be the same criteria. I have processed I queries so far. My current strength level, I have used y plus points to increase strength and all the remaining points to increase intelligence. First I queries, use y points to increase strength. All remaining points to increase intelligence. And this denotes maximum number of checks passed. And like overall, like this time complexity would be order n into m. And any questions on this before we try to optimize it further? And the way we increase this dp is like whenever we have ri equal to 0, if we increase strength, then dp I y plus 1 would be max with dp I minus 1 y. And if we increase like intelligence, then like number strength remains same, so it would be max with dp I minus 1 and 1. And like this will overall give us order n into n time complexity. Like any questions on this before you optimize it more? Like here the strength has increased, so like you have y strength up till I minus 1 query and plus 1 over here. And then whenever we have strength check, do plus 1 for like dpi from ri up to ending. And whenever we have intelligence checks, we first see like based on like ti is let's say the total count of points here. So like ti plus y like strength, and like if ti is the total number of ri equal to 0, then essentially this is our intelligence here, which greater than equal to ri means ti minus ri should be greater than equal to is less than equal to y. So like this is like adding plus 1 in some suffix. One second, like this is adding some plus 1 in prefix here. like only +1 for only cases up to like dp. What we need is like, okay, yeah, like this part was correct. Like dpi some y for all y greater than equal to r, some suffix. And here like ti is the total number of zeros we got, then ti -1 would be the count of all the values we have got. Then we pass a check if our current strength is greater than equal to this. So like this is like adding +1 in some prefix. Another way to say is like minimum value of intelligence is Ri is equal to saying maximum value of strength is Ti minus Ri, where Ti is the number of zeros we have seen so far, and that's how it is. So, and any questions on like order n into m idea before we try to jump it further? And like once we know this, like we can even use a lazy segment tree for like this is order n into m idea, like where you go over each point where you want to engage something. Like any questions on order n into m idea before I jump further? The next idea is like instead of maintaining this explicit subarray, we can also use a lazy segment tree. Because it allows us range addition +1. And whenever you want to do max query, we first look at what is the value for each dp value, then we try to find dp values again and then update the lazy segment tree again. And like there are more ways to do this problem probably, but I think my idea was a bit cleaner. And like with lazy segment tree, you would be able to do it in m log n, m square log n for update query and n log n for overall time query. Like for memory, like you will have to probably remove one dimension by reusing values here. Like you definitely cannot create an array 5000 into 1e5 array, and the idea would be to implicitly maintain this value I. Notice that to update dpi, we only need dpi -1. So before creating dpi, we can remove dpi -2 from the array. dpi -2. So at any point you will have around 2 into m values in your array only. Yeah, like swapping etc. is the idea, but like generally this is what people do to avoid memory limit. Like I'm not sure if like since m is 5000, this may get a TLE or may not get a TLE. Yeah, like I will jump on further, like probably like the idea is I started with n m square, then I came to n into m, then m square log n plus n log n. And if everyone understands it, then I will show how to remove even log m factor here. So first thing, let's like, do you understand like how you can use probably a lazy segment tree here or some segment tree to solve it in this time complexity? like lazy segment tree solution idea is like you maintain dpij, you may create a segment tree such that segment j is dpij. So like whenever you want to do plus one, you know like up to what prefix or up to what suffix you should do plus one here. And like when you want to take max query for ri equal to 0, first create an explicit array, like let's say ai is equal to, say again create an array like this, update this I, and then update segment tree again. The main idea is ri equal to 0 queries are only m times. So like this manual process of copying the complete segment tree into an array, taking maximum with some values, and then creating a segment tree again would only happen m time. And this segment tree size is m only. And when you want to do plus one to some prefix suffix, you can just look at what all values you have. Like based on ri, some prefix, like you can find out some range l and r for which you want to do plus one, and you can use segment tree there. So like this would be the lazy segment tree idea. Like I probably won't go into deep dive like how to use lazy segment tree to do plus one in some queries, but you can refer probably at coder library here on how to use lazy segment tree here, or you can probably learn over here. Like how to use lazy segment tree to add something in the range is mostly I'm avoiding here. And like you can probably refer some YouTube video etc. to understand how lazy segment tree works. So any questions on this solution before we even remove one more log factor from here? Now the next idea was like let's maintain diff iy as difference of dp iy minus dp I comma y minus 1. Instead of even maintaining this dp here, let's just maintain this difference array of all the consecutive values of y here. So if this is your dp array, and let's say values are 1 2 2 4 5 6 7 7 10, and the difference array here would be first value is as it is, difference 1 0 2 1 1 1 0 3, and if you increase plus 1 on this range, this value becomes 5 6 7 8. This is equal to changing this 2 to 3 here, and this 0 to minus 1, like only 2 points. Like if you want to add something in a range on an array, if you have its difference array, then adding something on the range is equal to updating 2 points in the difference array. So like we don't even need the lazy segment tree here. Instead of maintaining this dp array, we maintain this difference array. Whenever we need max query, we create this dp array using max query. And once we are done with ri equal to 0 update, we again create this difference array to diff array again. And the idea is like probably if you know how to change difference array to array, again, and if you know array to difference array, then we are good here. So like that was the idea, like we don't even need an explicit segment tree for this dp. we can maintain this difference array on whatever range we want to do +1 -1. We can only update two values here. And when we do ri equal to 0 query, we first convert this difference array back to original array, do max query, and then convert difference array to this array. Like this is array to difference array is for loop, and like difference array to this is generally prefix sum over here. And like this will allow us to solve this problem in order m square plus n update, and like this will easily pass the test cases. Like I can probably show the code as well. This is problem D, right? Like here it says I have this make difference function which has the original DP value here, and it creates a difference array here. And make DP function converts this back to this DP here. So first I assign DP 0 as 0 and everything else is infinite. Then I create a difference array here. Total points is number of points I want to update. Then the idea is like convert this back to DP state, do the max query for all the points we have, and then again converted this array back to the difference array here. And the idea is whenever we have ri equal to 0, we do +1 query here. Whenever we have ri greater than equal to 0, like this is like and like this is like and like this was the idea, and at last again I convert this difference array back to DP array and print maximum value I have got. So probably a lot of things over here, but like the last part was a bit non-trivial, I would say, or probably few people may find other ideas non-trivial as well. Like the idea is like if you have this difference array and you take prefix sum again here, like the way we convert difference array to DP array is by taking prefix sums again here. So sum up to this is 1, sum up to these two values 2, sums up to these two values 2. Like prefix sum of this difference array again gives us the original array. Sums of these values 5, this is 6, this is 7, this is 7, this is 10. And probably any questions on this one? Any questions here? Like the removing log factor was a bit non-trivial here. Like I think people may have some other ideas as well. Rather than difference array, like they looked at how many extra queries or how many checks in between two ri you can probably pass with some y, ri, etc. But that's a different story. So any questions on this before we even move further? Any questions on problem D? Okay, assuming no questions as nothing in the chat, and like in that case I will probably move on to like difference array is used. Like our problem is log factor due to lazy segment tree. range addition. And what I want to avoid is even this log factor here. And the idea was like, let's say we have this array. And like for this array, like if this is the difference array, and if I want to do +1 here, 3, 5, 6, then you will notice like the only change over here would be like this 2 has, this 0 has now changed to 2, and this 1 has now changed to 0. Like adding something in a range is equal to only increasing that value in at 2 places in the difference array. Like if you look at difference array of 1, 2, 3, 5, 5, 6, 6, 6, 7, 10, the difference array would be 1, 1, 2, 2, 1, 0, 1, 0, 3. So that was the main use case. Like I am regularly converting my DP array into a difference array for DP and difference array to back to DP. I am using this whenever I need Ri equal to 0 query, and whenever I don't need it, like adding into a range is equal to only updating 2 values in the difference array. So for range addition, I am using difference array, and for Ri equal to 0, I am using DP array to find all the maximums here. And like this was essentially the use case for difference array here. If you see, like my earlier time complexity was m square log and n log. Like dry running it on a large test case might probably be difficult, but I can try taking something. Like let's just pick this test case. Let's say this is our test case, -2. And like probably I will show one example on how it's working. I will probably not show everything here. So like probably when I start, before the first query, my difference array looks like this minus infinity. And if I look at its difference array would look like this 0, minus infinity, and 0 again. Now when I update query this, first I use this to override this DP here. And you can probably use suffix sum here, and you can notice that this is what you will get here. Or probably let's also include a 2 query here. A strength of 2 means like we can only increase this array here. So what I will do is like I will just increase this difference array by 1. Now when I have got this 0 array, I first use this difference array to override my DP array first. So here like you notice earlier I did not change it. And this is now changed to minus infinity plus 1. Then idea was to use like the max query, which we have used, like probably either we increase strength or we increase array here. And you can probably notice like this will look like this after you do a strength array. Like probably if you understood m square code, then you can probably notice like with r equal to 0, this DP array would look like this. And the idea is like once I have fixed this DP array again, I override this difference array back here. And this difference array will now look like this. Now when we have got this strength 1 again, what I will do is like I will do +1 on this range. +1 on this range is equal to just changing this value to 1 on difference array. And notice that I am not changing this DP array here right now. Then I got 1 again, which is equal to adding +1 on this array. Notice that I will not change this DP right now, but I will just increase this difference array again. Now I have got a 0. I use now difference array to override this DP array back. And you will notice like this will now look like this, 2 minus infinity plus 2. Then I use like update this DP for r equal to 0, and like this DP array will probably will look like this. And then I convert this DP back, I update this difference array again. And you can probably notice the difference array will look like this. And then you can keep proceeding further. And like that's the idea. Like when I am doing ri equal to 0, I use difference array to create DP array, update whatever I want to do on this DP array, and then update this difference array back. And like all like ri not equal to 0 queries are done on this difference array only. And essentially this is the solution we have. Any questions on this? Like it would be order m space m square dp. Like whenever you have ri equal to 0, you will do this back and forth conversion once and then update there. And whenever you have order n query, you will only update some values in this difference array. So any questions on problem D? Like there are some other ways to probably do it as well, like lazily compute how many values as the for a particular y you have got. But essentially everything boils down to do something over here only. Yeah, like probably frequency count might also work there. But this is what I ended up doing in the contest. Like this was my idea. Yeah, probably then I will move to problem E. Like I will upload my screencast so you can just look at like how much time I spend on each question. Like you can probably use Discord for sending the code. Like YouTube will probably add a lot of things here. And YouTube just blocks link if you post it in a comment. Okay, problem E, card game. In the most popular card game in Berlin, a deck of n into m card is used. Each card has two parameters, suit and rank. Suits in the game are numbered from 1 to n and ranks are numbered from 1 to n. There is exactly one card in the deck for each combination of suits and ranks. A card with suit A and rank B can beat a card with suit rank and C if one of the following. Like if the rank 1 card can beat any card of any other suits, or if both the ranks are equal, both the suits are equal, then a lower rank card can increase higher rank card over here. So it's more like probably trump card, etc. We have one particular suit that can beat any other suit or any other suit. Any card does not matter the rank. Or if you have the same suit here, then higher rank card beats lower rank card. And you cannot probably compare any other different suits with different types here. Two players play a game. Before the game, they receive exactly half of the deck each. The first player wins it for every card of second player. He can choose his card that can beat it, and there is no card is chosen twice. That is, there exists a matching of the first player's card with the second player, such that each player in the first card can beat the second player's card. Otherwise, the second player wins. So the idea is like you have some n into m card. You will give half of the cards to the first player, half of the cards to the second player. And on each turn, the second player plays a card. then first player should play a card and first player's card should beat the second player card. And this should happen for every turn they have. And like our goal is to like calculate the number of ways in which we can distribute all the cards that the first player wins on the every turn they play. And you cannot reuse the card which you have already played here. Two ways are considered different if there exists a card such that in one way it belongs to first player and other way it belongs to the second player. The number of ways can be large, so print it modulo some value over here. Any questions on the problem statement? Okay, then the idea here is like there are few observations here, and like I think I will mostly describe the thought process I had while creating this hints block. Like there are few critical observations to begin with. First, it's like let's pick a suit and try to distribute cards in the descending order. And when we are distributing, we will maintain two things. Up to n. Let's say we have decided these cards here. The idea is like, let's say I give P1 card to the first player, P2 card to the second player. And like, let's say how this is looks like. 1, 2, 3, 4, 5, 7, 8. Let's say M is 8 here. If I give this card to the second player, then I need one suit 1 card to beat it. Because any other card from the same suit cannot beat this 8. Let's say I give this 7 to first player, 6 to the first player, and then this 5 to the second player. The crux over here is now for this 5 I can use this 7 again. Let's say 4 is also given to player 1, 3 is given to player 2. Then I can use this 1 to beat this 2. And let's say I give remaining 2 cards to 2 as well. Then I can use this 2 to beat this 1 to beat this 2. And for this 2 I need suit 1 card again. And this is my main idea, like I will start giving cards from the highest number for every suit. And I will see like how many difference of card is there. And here you can see like I gave 3 cards to the first player. And 5 cards to the second player. And I needed 2 extra white suit 1 cards. And like probably let's try out some other configuration as well. Let's say let's give it to first one, suit 1 card we need. Let's also give this to the second player, we need suit 1 card. Let's also give this 2 to the first player, we need again a suit 1 card for it. Let's give this to the first player. First player. First player. First player. And let's give this to the second player. So here we can use this card to do this here. So overall we gave 4 card to each player. We need 3 suit 1 cards to beat player 2. And 3 player 1 cards are wasted here. Like you cannot use these cards to defeat any other card. Because for these two you definitely need suit 1 cards, and for this you can probably use this here. Like these are 2 important conditions here. Like here you see like the way I distributed was I gave 3 cards to the first player, 5 cards to the second player, and I only needed the extra difference cards of suit 1 to defeat here. So like this is in fact some good way. Here you see like I needed 3 suit 1 cards extra, and I gave 4 cards to each player, and like these 3 player 1 cards cannot be used to beat any other cards. So like this is not a good way. Like any distribution like this cannot give half of, we cannot give half of card to any player and you beat every card of second player with the first player. And this is a good way. Yes, like right now I am making it for a particular suit only. I am deciding for a particular suit, like how do I distribute card. In this distribution, I know like player 2 got 2 extra cards, and for those 2 extra cards I need 2 suit 1 cards. Here like player 2 did not got any extra card, but we needed 3 suit 1 cards from player 1 and 3 player 1 cards are wasted here. So my claim is, in a distribution like this, we cannot have equal cards given to both the players and even beat all the cards of player 2. But in a distribution like this, we can definitely beat every card of player 2 here, and there is no card wasted of, we did not wasted any card of player 1. So any questions here? So what we need is like number of ways. Let's say we give k extra cards to player 1. Extra, like any question so far here in a distribution like this and like this. Like why this distribution we can never defeat all the cards of player 2. Because these 3 cards cannot be matched with any other card of player 2. There would be some cards from player 2 that cannot be beaten here. While here there is some chance that we can have equal distribution for all the players and even beat all the cards of player. Any questions? Yeah, like right now I am distributing a particular suit which is not 1 in fact. Because for 1, like it does matter who plays first, because only when you know, like for each card of player 2 you have already, like it's a perfect information. Like player 1 knows all the cards given to player 2, because like player 1 knows all the cards on the table and he knows whatever card is not with him would be the card with player 2. So only when player 2 plays something, the player 1 can play an equivalent card that will defeat him and can ensure everything can be beaten here. Like if player 1 plays some card, then player 2 can probably play something else so that there can be a problem later on. Because half of cards are given to both of them, and like if in a deck of 20 52 I know 26 are given to me and the remaining 26 cards are given to other player, I definitely know what all cards other player has and other player also knows what all cards I have. So it's a game of perfect information, and if I have to defeat every card which is played by the other player, then other player must play first. Like to give some examples here, like let's say this card, we have a deck of 4 only. This is given to player 2, this is given to player 1, this is given to player 2, this is given to player 1. If I play this on my first turn, player 2 can play this on the same turn. Although it's beaten, but you see next turn my card cannot defeat the other player, this card. Or if I play this, then the other player can directly play this card and it won't be defeated. So it does matter who is playing first here. And you also notice like for the suit 1, you cannot have some extra suit 1 cards from somewhere. So we need number of ways. As number of ways to give to distribute suit 1 cards let's call it S1 such that player 1 has extra K cards. K cards and no card is wasted for player 1. Like let's say I have some way to find this DP as number of ways to give suit 1 cards to some player so that player 1 has extra K cards remaining and all the other cards, all the cards of suit 1 given by player 2 can be defeated by player 1. Like the idea would be same here, just that we can no longer use suit 1 card, so number of 1s higher would always be more than number of 2s here. And let's also define some suit A K as number of ways to distribute non-suit 1 cards such that player 2 has extra K cards. And no P1 card is wasted. Yes, like all the other suits will have identical distribution in fact. Like I have these two ways of defining S1 case number of ways such that player 1 has extra K cards and every player 2 card was defeated by player 1 card here. Yeah, like that's fine. Like all player 1 cards are before all player 2 cards. Like that is some valid way here of distribution here. Like this is one valid way of distribution here. I will say like player 1 has 2 extra cards and like this is not allowed. This is not allowed. Although player 1 has only 2 extra cards, but in this distribution, like these cards cannot be defeated by anything here. So this is a bad way here. So like this is not allowed. But this is allowed. So like my DP method will not counter distribution like this, but it will counter distribution like this. Like I will count this in S12 and I will not count this distribution in S12. I'm yet to decide on like how do we calculate this S1, S2, but that's what I'm setting some field on. And like let's say like X2 is the number of extra card in player 2. X3 is the number of suit 3 card for player 2. X4 up to Xn. Like these are the ways I decided for S1. Then my idea is like whatever extra card I have for suit 1 should be equal to extra card for the second player on all the other suits I have. So in this case, I will add this S1K into SO X2 into SO X3 up to SO Xn here. This would be one valid way of distribution here. Like player 1 has K extra card and all the suit 1 card player 2 had, player 1 also defeated them. And SS2 would be the number of ways to distribute suit 2 cards such that player 2 has X2 extra card. For that we'll take some cards from the suit 1 and all the other cards which every suit 2 card the player 2 had and every suit 2 card the player 1 had, player 1 also defeated every such card of player 2 as well. And like I will add this to the sum. K will vary from 0 to M, like all the possible values, and X2 to Xn will also vary all the values here. So like I am yet to define on like how do we calculate this S1, how do we calculate this S0. But you see, like once I know these values for S1 and S0, like I can probably use a knapsack DP here. Like the idea would be like DP J denotes. I have decided on 1 to J suit. And I still have P1 as Y suit 1 card remaining. Then from here you can decide how many extra card I plus J plus 1 suit should give you, and you can remove that corresponding count from Y here. So like any questions, like once we know this S1 and S0, how do we calculate the final answer? Like the idea is like DPJ Y denotes. I have decided on suit from 1 to J, and I still have some Y suit 1 type card remaining with me. And like the next idea is like, then let's say I give 5 extra card to player P2. Then my answer like DP J plus 1, like the extra card I would remain from suit 1 would be Y minus 5, and I can do this plus equal to dpjy into so5. Like these are the number of ways so that player 2 gets 5 extra card and all the player 1 cards have defeated the player 2 cards of the same suit. Y denotes how many extra card I had before deciding on J plus 1 suit. And because I used 5 cards from this Y here, like I add this to DP0. And at the end of the day, my answer would be DP and 0. Like no extra suit 1 card remain with everyone and everything is happy. Like kind of knapsack DP, but probably some other way to do it as well. And like if I have this 6 here, this would be y minus 6y and this 6 here, and so on, like a for loop to decide on how many extra card I should give to player 2 here. And if I know s1 s2 overall here, like overall this part should take n into m square time. Although like there are ways to optimize it to m into log m into log n, but I will probably call it as an homework exercise. Left to readers to figure it out. Like solving this problem in this time complexity was enough for this problem. We don't really need it, but this part can also be solved in this time complexity. Okay, now let's jump back to SO and S1 part. Int FFT. Int FFT or entity with exponential power exponential function. Power exponential. Like you will need this log n comes from exponencing to the power, and m square becomes m log n using FFT and MTT. So let's jump. Now let's jump on to x0k. We want to basically count, like we are given k extra cards to P2 and every player 1 card was distributed to player 2 card. Like S2 and K is a bit similar, to be honest. The idea is like I maintain a DP array again, which goes from minus k up to m. Negative index, I am using a negative index here, but you can probably see like how it's working. I first say like number of ways like no one has any extra card is 0, is 1. Like this essentially denotes like I am using same DP values again and again, but the core idea I have is like I will give card like this, first m, then m minus 1, then m minus 2 and so on up to 1. I will ensure like the player 2 never has more than k cards, and like different like number of cards given to player 1 minus number of cards given to player 2 is some u over here, let's say. Then this I maintain like, and let's say I have given up to 1 I up to ith card here. I have given these cards. Then this value will essentially correspond to DPI and U over here. Like DPIU here denotes like player 2 never had more than k extra card. Every card of player 1 was able to defeat some card of player 2. and we never needed more than k extra card so far. And the idea would be like, if we give it to next card, if we give I minus 1 card to P1, then this DP adds this to something. Like, because I am giving it in descending order, I minus 1 and U plus 1. And I can give this card I minus 1 card to P2 only if this U is greater than minus K here, and this will contribute to DP I minus 1 and U minus 1. And at last I need like DP1, like when I have distributed all the cards from 1 to M, and minus K here. This is what I really need. Any questions on like what I am doing here? I start with saying like I have not distributed any card, and difference of cards given to player 1 and player 2 is 0. Then let's say I have distributed I cards so far. Player 2 never had more than K extra card, and current difference of count of cards for both the players is U. Then if I give this card I minus 1 card to P1, then this P count increases by 1, which essentially says overall U increases by plus 1, like this. And if I give this I minus 1 card to P2, then this P count increases, so which essentially decreases U by minus 1 here. So like this adds to this, and I can only give extra card to U if the extra card so far given to player 1 is less than K. Like that, basically the difference of cards so far for both the players is less than K. And at last I need like I have given all the cards, and extra K cards were given to player 2. Any questions on this idea? Before I jump on like how do we calculate S1K here? Well, S1 is also similar. We call the same method with K equal to 0. And what we essentially look at is like DP1 Y, where Y would be definitely greater than 0, would be the number of ways to give Y extra card to player 1 such that player 1 defeats all the other player 2 cards here. Same method with call it with K equal to 0, and whatever value, like earlier we were looking at only at minus K here. Now we look at all the Y's greater than 0 equal to 0. Like this is another way to say like player 2 never had any extra card from others who required to defeat it. And at the end of the day, player 1 had Y extra cards here. And like this is essentially the solution for S1K as well. This gives me a number of ways to distribute M cards such that like the second player never had more than minimum number of minus Mn cards which I have given here. So a DP L vector of length this. So basically instead of minus 5 I am shifting every value by 5 here. So this would be the place for 0. Now I am distributing all the cards from higher to lowest. And like what this is my difference for cards assigned to both the players, and I am storing this value at this place. So if I want to give some extra card to player 1, this difference increases. If I want to give one extra card to player 2, I can give only if I do not reach more than -mn cards here, and I add this value here. And this DP at the end of the day denotes, like, every index denotes how many cards someone needs here. So the idea is for P1, I call it with 0. Like, so basically player 2 should never have more cards than player 1 if you look at whenever you are distributing cards here. And then I also calculated for all the possible differences of n. I distribute m cards and maximum difference allowed is, let's say, -5 here. Then this, the 0th index here denotes how many cards I need for -5 here. So like this is way to distribute all the card other than first card, where the player 2 will have 5 extra cards and everything would be a happy path for us. And then this other m square part which I discussed earlier. We can do this also in m into log m into log n. This part would be done using FFT, and this complete loop would require some power exponential etc. there. And at last, there should not be any extra suit 1 card for player 1. So DP0 would be my answer here. Any questions here before we jump on to the F problem for today? And to be honest, like, I don't know how to solve G, but among F, I found this. Like, tell me how to make DP strong. There is only one way. Try to solve more DP problems. You can probably start with CS and use our guide as well, USSM. Like, so like if you see, like, I probably had 2 problems with DP here. No, like, I definitely did not solve in 8 minutes. Like, before jumping to F, I tried spending some ideas on E. So like before moving to F, like, I realized everything before realizing that I only need this -k here. So let's just say, like, probably before moving to F, I had all the observations except one required for E. And when after solving F, when I came back to E, like, I instantly realized the final observation and just coded it. So like, use the time between D and E, F was distributed between both F and E. Okay, I will probably move on to problem F. Choose your queries. You are given an array A consists of n integers numbered from 1 to n. Initially, all of them are 0. You are given Q queries. The ith query consists of 2 different integers xi and yi. During the ith query, you have to choose an integer p which should be equal to xi or yi, and an integer d which would to be either +1 or -1, and change that this by doing +1 or -1 to that chosen element. So basically, the problem statement is giving you 2 indexes. Among them, you choose one index, and then you choose +1 and -1 and change that value accordingly. After each query, every element of A should be non-negative. Like, you cannot have negative numbers here. And we have to process all queries in such a way that sum of all the elements of A is minimum possible after we are done. And then we have to print, like, how do we assign these queries here. Any questions on the problem statement, or should I try run any sample before I jump onto the solution for this problem? Okay, like, let's probably look at this problem in a different way. Let's probably just take these samples here. 1, 2, 1, 2, 3, 2, 3, 4, 3, 2. My idea would be like I will create a graph with 3 nodes, 1, 2, and 3. And for every node, I will create an edge here. So like 1, 2 query means I have this edge. 3, 2 query means I have this edge. Like, do I have 4 nodes here? Yeah, 4 nodes are there. 3, 4 means I will add this edge in this graph. And again 3, 2 means I will add one more edge like this. So what I am doing is I am creating a graph with n nodes and q queries. Like, look, input as a graph. Like, you have been given n nodes and m edges here for and every node here. I did not realize this is given, so my problem does not assume this case either. So like this would be the graph I will create for this example here. Then the main idea is first give direction to each edge here. Like for example, we can give a direction like this. So like basically first you add n and m queries. I completely change it to a graph problem. And I am saying look queries as a graph, as an undirected graph. And the next thing I am saying is now give some direction to each of the edge here. So if I give an directions like this, my graph becomes this 1 to 2, 2 to 3, and 4 to 3. Giving a direction means for that particular query, I have picked that particular xi. Xi to yi direction means pick yi. And from yi to xi means pick xi. So I am not saying how to optimally decide it, but I am trying to say like change it to a completely different problem from what was given to us. So first, some queries and some numbers were given you. I completely change it to say like look at it as a graph problem. And then I am saying for each edge give some direction to it. And giving direction means deciding which xi you want to choose here. And the idea is whenever you have looked at this, you will change it like this. If you want to, if AP is 1, change it to 0 by picking -1. If AP is 0, change it to 1 by picking 1 here. So initially you will start with 0, 0, 0, 0. When you have this edge, your AP2 becomes 1. When you go for this edge, let's say first you go for this edge, your 3 will become 1. Then let's say you went for this edge, you made it again 0. And then you went for this edge, then you got 1 here again. Like right now I am not minimizing it, but I am saying like if you pick some edge, some xi yi, then you can also look that as a directed graph here. So any questions on this part first before trying to minimize the sum of all the values at last, whatever blah blah we need? Yeah, like good question, Raj. Like how do I represent +1 -1 in this graph? Like so far I have only decided edges here. So yeah, like right now let's focus on the final value instead of how to decide it in between. My claim is AU is parity of number of incoming edges to V. No, not DP for this problem, or probably you can call it DP. So like if you look at this, there are no incoming edges to 4, so it will always be 0. There are 3 incoming edges to this 3. So we will do +1 2 times and -1 1 time, and overall final value we will have is 1 here. There is only one incoming edge to it, so we will do only 1 here. There are no incoming edges here, so we will do 0 here. And you see like these are the same numbers I have. So my problem now from x, y, +1, -1, from that has reduced to, I have been given an undirected graph. I have to give some direction to all the edges such that number of nodes which have an odd number of incoming edges is minimum possible. Because odd incoming edges on a node denotes there would be final +1 there. Even incoming nodes denotes there would be 0 values there. Like so far order of queries does not matter here. Like for example, if I had this graph like this, then also like the values leave. No, I am not minimizing number of nodes with in degree 0, but I am minimizing the number of nodes which have an odd in degree. Because like problem does not say like sum should be minimum at every possible step. Problem just says after we process all the queries, sum of values in A should be minimum possible. And what I know is like if I have an odd degree, the final value is 1. If I have an even degree, the final value is 0. So as long as I minimize the number of nodes which have an odd degree, then my final value would be minimum as well. Odd degree will make it 1 and even degree will make it 0 again back to 0. So any questions on this part before we proceed on like algorithm on how deciding edges here? So like I am not yet deciding like whether to give +1 or not. My algorithm would be more on the lines of first decide direction of each edge, and then once you have decided, process each query in the order which have been given to you. Whenever you have got a particular query, look at current value of it. If it's +1, make that value 0. If it's -1, make that value +1. And the idea would be like at last, if I have touched a node odd number of times, the final value would be 1. If I have touched, like for example, let's look at this here. 2 to 3, 4 to 3, again 2 to 3. I will do +1 for this, -1 for this, +1 for this, overall 1. Let's say the order is different here. 4 to 3, 2 to 3, and then 2 to 3. Then also like I can do +1 here, -1 here, +1 here. Basically, once I have decided the direction, I will process all the queries in the order which are given to us and change +1 to -1, like, and -1. So like the value here is 1, the value here is 0, the value here is again 1. The value here will become 1, -1 will make it 0, and 1 will make it again 1. This can be one way. Another way can be like if you let's say have 5 queries, 5 edges which move on to a particular node. You look at first 3 nodes which come to that edge, make +1 there, and last 2 nodes -1 there. Or if you have 10 edges, you can do first for +1, second edge which is on this -1, +1 -1. Or if you have 10, you can do +1 for first 5 and then -1 for last 5. So that final value is 0. So you see this, right? Like what I am doing after I am deciding all the edges. Like once I have decided all the edges, I have an algorithm to find like minimum value over there. The only thing I want to minimize is like total number of nodes which has an incoming odd degree should be minimum possible. So any questions so far? Okay, now like the problem we want to solve is we have some graph, some edges. We want to give direction to each edge such that number of nodes with odd degree is minimum possible. Let's probably first solve a simpler problem. We have been given a connected graph and it has total even number of edges. Let's first solve this problem first. Let's say we have been given one graph. The graph is connected, like from every vertex you can go to any other vertex. And total number of edges in this graph is even. And I want to give direction to each edge such that number of incoming edges on each node is 0. Each edge has even incoming degree. Each node has even incoming edges. Like you see, like how do I jump from, if I know how to solve this problem, then how can I solve the previous problem? I will look at all the connected components. For every connected component that had even number of edges, I will use this algorithm to make everything 0. And if a connected component had odd edge, I will remove one edge from here, make everything 0, and then add that edge back over here to get 1 plus 1 there. Like if I can solve this problem, like I have a connected graph and I have total number of even edges. I give direction to each edge such that every node has even number of incoming edges. If I know how to solve this problem, then I can solve my previous problem too. I look at all the connected components in the graph I had. If a connected component had an odd number of edges, I remove one edge, solve this problem, and then put that edge back and have plus 1 on one of the nodes. If the connected component has already even number of edges, then the answer is same. So basically my answer, like minimum value, would be number of connected components that have even number of edges, odd number of edges, sorry. So any questions, like if I know how to solve this problem, then I would be able to solve my final problem as well. Because if a connected component has, let's say, 5 edges, then it must be the case that there is at least one node which is 1. And if a connected component has, like, because you see, like sum of all the values should be equal to, like whenever you are doing plus 1, minus 1, whatever you do, if you do it odd number of times, you will get an odd number at the end of the day. So the minimum odd number is 1 here. Any questions? Like if I know how to solve this problem, I can solve the complete problem. This is in fact the final bits and pieces I need over here to completely solve this F. Any questions? And in fact, like this problem has appeared quite many times. Like I have one of the links handy. Like this was the first time when I have seen this problem, and after that I have seen it a lot of time. There is little time left until New Year. For some reason, Seb decided to make a present for his best friend. He made a connected, undirected, simple graph with n vertices and m edges. Since Seb does not like odd number and his friend does not like undirected graph, Seb decided to direct each edge in one of the two possible directions, such a way that integrity of all the vertices of the resulting graph is even. The integrity of the graph is number of incoming edges, etc. Find one possible way to direct them or determine that is not possible under the given constraint. So here, like the idea was, if total number of edges were odd, it was not possible, and if total number of edges were even, there was some way to do it. So in this cases, there were in this connected component 3 edges, so -1 here. In this test case, there was a way to decide over it. So like the idea is simple. Like now I have a connected component. Let's call it CC and even edges. One idea that works is like you can probably greedily choose, like let's do a DFS here. Like let's say this is a back edge in the DFS. Let's say this is how my graph looks like. Like basically the way I have drawn this graph is like if I do a DFS from 1, orange would be my forward edges and blue would be my back edges in this DFS. And the idea would be whenever I am doing this DFS, for all the back edges, I will direct them to this node. Like whenever I am done, like let's say 1, 2, 3, 4, 7, 8, when I went to it, and 8 blue were the back edges. So the idea would be to direct all these 3 edges on 8. And when I am going back from 8 to 7, I see like 8 has odd number of edges. So I will also direct this parent edge on this side, so that odd has 4 edges on it. When I am on 7, like I see there is no edge incoming to 7. So I will direct this edge like this. When I go back to 3, I see like there is one incoming edge to 3. So I will direct this parent to child edge on this side too. From then 4, I will move on to this 4 to 6. For 6 first, I see there is no incoming edge here. So I will direct this 5, 6 parent edge on this side. These edges on parent side would be directed like this. And I see like 5 now has an even edge. So I will direct this 4 to 5 parent edge on this side. And this 1 to 4 back edge on the DFS would be directed like this. And since 4 has an even edge, I will even direct this parent edge on this side. And once I am here, like I see like 2 has only one incoming edge, I will direct this edge here, and everyone has now even number of edges. The idea is do a DFS. Whenever you go to a visited vertex, direct that edge on your side, to be honest. And when you are returning from parent, you just see like what is the degree of my current nodes have. If it's odd, direct parent edge to you. If you already have even edge, direct your parent edge to your parent side. And in the worst case, what can happen is like only one can have odd number of edges, even number of edges what are being forced here. All the other nodes will have an even degree, and that was essentially the solution for this problem. Like if the connected component has even edges, this algorithm will ensure that everyone has even in degree. And if the connected component had an odd degree, like this algorithm ensures like only the root node has an odd degree. And like this is essentially the solution for this problem. I can probably jump onto the code for this one. But at first I am taking the graph as input and everything is there. Then I have this visited vector and I am doing a DFS here. If I have already visited this node, ignore it. Otherwise, do a DFS from this node as a root. And this is the edge we have for parents. False denotes like whatever I did not took the direction of the edge. Like true denotes like the child already took that edge on his side. False denotes like the child forced that edge to the parent. So the node is already visited, then I won't change anything here and I will rather force the direction of this to whoever calls this DFS function. Otherwise, I might mark current node as visited. I ignore the edge using which I came to the parents. And otherwise, I call it for the child. If the child took its edge on his side, I already ignore it. Like this should be like this rather. Edge denotes I have already decided the direction for this edge. Otherwise, I call for child, and if child took this edge on his side, I do nothing. Otherwise, I direct this edge towards my current node, and like this vector essentially denotes direction of all the index of all the nodes which are on this side. If this was root node, like it doesn't really matter if I did not add odd edge. If I have odd edges right now, I won't be able to do anything here. Otherwise, if I directed odd number of edges to my current node, then I said also direct the node from the parent using which we came on this tree. So that the edges directed on current node are even now. And I say to the parent that I have already took this edge along my side. And if I have directed even number of edges on this node, then I say like parent you take that node rather than giving to me. And this was essentially the solution. And once I have decided for each node which direction it will give to, I can essentially print all the answers I want. So this was the idea for this problem. And for Y Combinator, you can probably check out my blog here. And this essentially, yeah, like Y Combinator has a name in lambda calculus or something like that. But the exact same purpose we have used. So like Y Combinator has some interest in theoretical computer science and we are using it same. And TLDR is like I am doing it recursion in some special way and you can find the reasons in the blog I have listed here. Like I am mostly using Eknerwala setup and like there are two scripts for it and one computer programming companion extension. So any questions on any problem or any question in general before we wrap it up for today? Like most of the time I paste these links here, but yeah, like you can find these too. Like I have pasted two scripts I am using, and then one this competitive companion extension. Like I don't know how much F was rated, but I think it would probably be rated to more than 2000 based on number of solves. But definitely the idea required here has appeared quite a lot of times. Like I at least remember solving the same problem 4 or 5 times. Like basically a graph which has even connected graph, even number of edges, direct such that everyone has even number of incoming edges. Like I'm pretty sure I have solved it in 3 or 4 times, but that 3 or 4 times is on the 7 years I have solved. Yeah, like I created this hints blog, and like this essentially contains all the links we have. So like in 7 years, I have seen this problem 3 or 4 times at least, or probably more. So probably the first time for this year, but yeah. So that's how I was first. And yeah, thanks everyone for joining today. Yeah, like the way I have set is like generally if I choose like I have some to define like latency of how much lag I should have. So choosing it normal creates a lag for 30 seconds and probably not a good experience. And there is an option to choose ultra low latency, but in that case like the quality degrades a bit. So I have chosen it some minimum. So the lag I believe is around 2 3 seconds between when I speak and when chat ceases. Yeah, like Andaman and Nicobar is a pretty nice place. I think I am a tester for this contest, so won't be able to participate. And like on the same day, we also have Hacker Cup, so I can't have a stream for this contest either. So yeah, that's where we are. And I think thanks everyone for joining today. If there are any questions for people in the chat, I would be happy to answer them. Otherwise, I will just end the stream now. Like how to be better than me? Like it's not a hidden secret. Like I have already answered it quite a few times. The step one would be to join the Discord server I have and check a channel over there. Like on my Discord server, I have this channel roadmap to read in 2 minutes, where I have advice on like most important question people ask to me, like how to get better at competitive programming. So like the advice are mostly like do ABC. There is a no-brainer for it. If you are looking for standard problems on some topic, X can be DP, graph, anything, then these are the resources you can probably refer. But the most important advice is participate in all contests, absolve, read editorials, and try to absolve it later. What I did when I was expert or below, when I was targeting master rating, and so on. And the most important advice is to get better from Omnic is to get better at X, you should do X. X can be anything, competitive programming, DP, graph, anything development, anything over here. And I think that's all I have. Thanks everyone for joining today and whoever is here so far. And I think I will and my stream now. Like this is Discord server link in case anyone wants to join. And thanks everyone for joining.